Okay, so now we consider another example of an improper integral of type 1. First, it's wrong to write your integral in this form, limit when r goes to infinity from negative r to r of the integral. So what we do according to what we defined in a previous video, that you should write this as integral from negative infinity to infinity x sine of x squared dx equal integral from negative infinity to some number a, we can make it 0 if you want, x sine x squared dx plus integral from 0 to infinity of x sine of x squared dx. Now, we know how to compute, each one of these two integrals, we know how to write it as a limit and then find the value. So what I'm going to do first is I'm going to pick one of them and compute the improper integral. Let's start with integral from 0 to infinity. Now, when I find this, if this is divergent, then I stop and the whole integral will be divergent. If not, then I have to find the other one and then I will add them up at the end. So this integral is, by the definition, that's the limit when r goes to infinity, integral from 0 to r x sine of x squared dx. Okay, let's compute the integral first. Okay. So here, just on the side, we're going to compute the integral of x sine of x squared dx. To compute this integral, notice that the inside function x squared has derivative 2x, which is a constant multiplied by x, so it will make sense to choose u to be x squared. That means that du is 2 times x dx, so dx is du over 2x. Now, this integral becomes integral of x multiplied by sine of u multiplied by du over 2x. Cancel out the x's, you get 1/2. So the integral of 1/2 sine u du, which is negative 1/2 cosine u plus constant. So this is negative 1/2 cosine of x squared plus the constant. Okay. Now, I want to find the limit. I want to plug this in. We can drop the c. We mentioned this before. Because that's going to be an indefinite. We can applying the fundamental theorem of calculus part 2, so the c will cancel out. So basically, what we have is this integral of 0 to infinity x sine x squared dx. This is the limit when r goes to infinity, negative 1/2 cosine of x squared between 0 and r. Now, this is equal to limit when r approaches infinity, negative 1/2 cosine of r squared minus negative 1/2, so plus 1/2 cosine of 0 squared. Okay, now this is fine. That's a constant. This is actually just equal to 1/2. Okay, but the problem is with the first part, when this guy goes to infinity, so when r approaches infinity, this limit does not exist. So the limit, this limit does not exist. The reason this limit does not exist is because, the cosine function keeps oscillating between negative 1 and 1. Okay, and so it will keep doing this. It will always have this behavior near infinity as well. So here, this is like cosine of a number approaching infinity, like it's like cosine of infinity, and that's going to be undefined as well. It's not going to exist as well, because you will have it's not going to approach a single value. So as a result, the limit of the whole, improper integral, well, 0 to infinity, this does not exist. Now this results that the original integral from negative infinity, so no need now to check the other integral, which was from negative infinity to 0. Once you get one of them that's divergent, then the whole integral is divergent. So this results that the integral from negative infinity to infinity x sine of x squared dx is divergent. Now we can consider another example. Suppose that I have the integral from 0 to from 1 to infinity of 1 over x squared dx. Now again, by the definition, so here's another example. This is equal to the limit when, remember, like this function is continuous over the interval 1 to infinity. So this is the limit when r goes to infinity, integral from 1 to r 1 over x squared dx. So this is limit when r goes to infinity. The antiderivative of 1 over x squared, this is x to the power negative 2 plus 1 over negative 2 plus 1 from 1 to r. So this is the limit when r approaches infinity, negative 1 over x between 1 and r. So this is the limit when r approaches infinity, negative 1 over r minus negative 1 over 1, so plus 1. Okay. When you take the limit of this when r goes to infinity, the result is 1. So it's defined, the limit exists, then the integral converges.